Engineering. There is no way of explaining engineering without going into each category, but for now, the most simple definition of engineering is the use of scientific principle to design and build machines, structures, and other items, including bridges, tunnels, roads, vehicles, and buildings. Of course, these aren't the only things that can be designed and built using engineering. Look around you. Chances are, if something is man or machine made, it was probably designed by an engineer in order to be sold for commercial use. Let's start off with the basics. Engineering consists of four major categories: mechanical engineering, civil engineering, chemical engineering, and electrical engineering, each with their own set of intricacies and challenges. So let's start off with mechanical engineering.
お前はもう死んでいる。何?
Mechanical engineering is probably the most popular category of engineering. One of the reasons why it's so popular is because of how versatile it can be. Mechanical engineering branches out into subcategories like aerospace, automotive, mechatronics, manufacturing, construction, and so on. Mechanical engineers use many advanced maths and physics subjects in order to supplement specific subjects like aerodynamics, fluid dynamics, thermodynamics, dynamics, and more. You even take some circuit classes along with statics and other variations of subjects that come from the different engineering disciplines, making it the most diverse engineering in the market. However, some other engineering disciplines dive deeper into much more specific subjects, so let me introduce. Civil engineering is vastly different from mechanical engineering. This may not be as versatile as mechanical engineering, but it is the oldest form of engineering and one of the most, if not the most important category of engineering. Whatever you're standing on right now, if you're watching this video in your home, at work, or anywhere else, there's a huge chance a civil engineer was involved in designing and constructing the floor, walls, and the structure around you. Being that I recently graduated with a civil engineering degree, I am biased, but I also have more insight on this branch of engineering, more than any of the others I will cover in this video. Civil engineering is also a little weird because, at least in college, it branches out into two main types, which are civil engineering and environmental engineering. Weirdly enough, one of them is the same name as the umbrella term, but it's because environmental engineering is technically part of civil, but it's different enough to warrant its own category.
How?
Now that we have that out of the way, civil engineering encompasses structural, construction, geotechnical, transportation, and hydroengineering, and even more. Each of these categories have different applications, but they all deal with designs centered around civilization. However, environmental engineering is vastly different, although it does go hand in hand with civil engineering. Environmental is more chemistry-based and deals around subjects like pollution, contamination, and waste treatment. This in turn helps improve recycling, waste disposal, and public health, which is more important than you think. What I decided to pursue in college was structural engineering. I graduated with a bachelor's in civil, but I decided to do my master's with a concentration in structural engineering. This side of engineering offers a very specific field of subjects that are versatile in its own unique way. Structural engineering requires the same advanced mathematics and physics courses you would take as a mechanical engineer, but concentrate more on non-dynamic subjects. Some of these subjects include static mechanics, solid mechanics, structural analysis, steel design, concrete design, and more, especially when you get to grad school. What I learned this year was wood structure analysis, precast concrete design, and advanced structure analysis, where we learned how complex structural systems work. They incorporated springs, thermal stress, and more. Personally, I really love structural engineering, and there is so much to talk about, not only in this, but in every category of engineering. Maybe I'll do an in-depth video on each in the future, but for now, let's move on to the next category of engineering. Chemical engineering is debatably the hardest form of engineering studied in college. It is also one of the highest grossing categories of engineering in the world. In simple terms, chemical engineers are involved in planning and production processes of different products for consumer markets like cosmetics and cleaning supplies, but they also deal with massive projects like nuclear engineering. The list of chemical engineers consists of biochemical, nuclear, petroleum, pharmaceutical, and cosmetic, and many more, but these are the most popular sectors. Chemical engineers use chemistry in an industrial application in order to provide products or provide safety to the common public. It's hard to really talk about chemical engineering without getting super specific about their unique subjects, but for the most part, from the information I was able to gather from a friend of mine who is a chemical engineer, she explained a few of the courses like organic chemistry, process controls, and other things you would need in order to operate a chemical plant. One of these subjects she explained to me, which I found very interesting, was separation design, where you're in charge of designing systems to separate different chemicals, which has a huge application in the industry. Now for the final category of engineering we have electrical engineering. Is a very diverse field of engineering, but in a different way from mechanical. Mechanical explores the most subjects throughout engineering, combining civil, electrical, and chemical. However, electrical is the most applicable form of engineering in the industry. You find electrical engineers working on projects with chemical, civil, and mechanical engineers where electronic systems need to be developed. For example, an electrical engineer can work on an electrical or computer system in a car, whereas a mechanical engineer designs the rest of the systems. From what I've seen, electrical engineering is broken into two different categories, just like civil engineering. It is broken into electrical engineering and computer engineering, where electrical is focused more on the electronic systems, while computer engineers focus on the operating systems, but they typically work hand in hand. Electrical engineers can be broken into further categories such as energy system engineering, power engineering, microelectronic engineering, and more. In college, a lot of the courses you would take as an electrical engineer are classes like circuits, signals, heat transfer, and more that complement that of electronic systems. They also take the same rigorous and math classes as the separate categories of engineering, so don't think it's any easier or harder than all the rest. In conclusion, I personally think engineering is a fantastic field. It's a fusion of math, science, technical work, and art in many cases. If anything, I would have to argue that engineering is somewhat of an art form, where you apply all of these subjects to make something that works and solves problems. In my opinion, I think it is the best career to get into. However, I do warn that this is not for everyone. Unfortunately, universities try to make the program as appealing as possible, but they do not mention that it is incredibly competitive, and if you're not willing to put in a crap ton of work and effort, you're going to have a very rough time in this major. Maybe for a future video, I will talk about what it's actually like to be an engineering student, but for now, I hope you enjoyed.